Okay, time for our more advanced example number 3 from our notes, graphing rational functions. Remember how we started yesterday, where we looked at the parent function of a rational, and then the more advanced rational functions have multiple branches. Today we're going to see a rational function that also has multiple branches, but might be a little bit more difficult to input because we have a different kind of asymptote. So the rational function we're graphing is 2x squared divided by x squared minus 16. The parent function is still the rational parent function 1 over x. My vertical asymptotes, the value of x for y does not exist. I find in the same way. I'm going to set my denominator equal to 0. So x squared minus 16 equals 0. And remember, the reason I'm setting my denominator equal to 0 is because when I divide anything by 0, I get an error. I can't divide by 0. That's why an asymptote exists there. So I'm going to solve, add 16 on both sides, and then I'm going to square root both sides, which remember when we square root, we get the absolute value. When we square root the x squared, so I have plus or minus 4. My two asymptotes are 4 and negative 4 for this rational function. That means at 4 and negative 4, I have vertical asymptotes. Now, because this rational has x squared in both the numerator and the denominator, I am going to find my horizontal asymptote by taking the coefficients of x squared in the numerator and x squared in the denominator. So my coefficient in the numerator is a 2, and in the denominator is 1. 2 divided by 1 gives me my horizontal asymptote. And we're going to practice more with finding these horizontal asymptotes on Monday. So y equals 2 is my horizontal asymptote. My domain is split up into 3 intervals, just like yesterday's domain. So negative infinity to my first asymptote of negative 4, union negative 4 to 4, all the way to my second asymptote, union 4 to infinity. Because I have 3 separate intervals, I again am going to create an XY table. I'm going to test one value before the first asymptote, 3 values in the middle interval, and 1 value again in the highest interval from 4 to infinity. So my value I'm going to test from negative infinity to negative 4 is negative 5. But again, you could test any value you want. So I'm going to input negative 5 into the original rational. So I have 2 times negative 5 squared divided by negative 5 squared minus 16. I'm going to simplify that. 2 times 25 is 50. 25 minus 16 is 9. And just like the previous day, I'm going to convert this to a mixed number, which is 5. 9 times 5 is 45, and then I need 5 more to get to 50. So positive 5 and 5/9. I'm going to plot that point, approximate it, which means my branch for the first interval is in the positive. I'm going to test 3 points in the middle interval. I'm going to test negative 3 because it's closest to the asymptote. I'm going to test 0 because it's approximately in the middle. Actually, it is exactly in the middle. And then I'm going to test 3. So negative 3, 0, and 3. I'm going to use my scratch paper to test negative 3. So I have 2 times negative 3 squared divided by negative 3 squared minus 16. So I have 2 times 9 is 18 divided by 9 minus 16, which is negative 7. I'm going to convert that to a mixed number. It's negative 2, because 7 times 2 is 14, and 4 more sevenths gets me to 18. So this is a negative value at negative 3, negative 2, and 4 sevenths. I now know I'm either going to have the cubic shape starting in the negative direction on this left side, or a quadratic shape. So I need to test more. I'm going to test 0, and just like yesterday's problems, when I plug in 0 to this numerator, I get 0. 0 divided by any number is 0. I'm then going to test 3. And actually, when I test 3, looking at my work for testing negative 3, I know I'm going to get the same value. You can plug in 3 if you want, just to make sure, but you will still get negative 2 and 4 sevenths. So I know I have the quadratic shape in that middle interval. Lastly, I have to test an x value in the third interval from 4 to infinity. I'm going to test 5. And just like from the first point, testing negative 5, when I test 5 instead of negative 5, I'll get the same value. Again, you can test if you want, but it's not necessary. So 1, 2, 3, 4, 5, and 5/9. I know my last branch is also in the positives. My range has a gap. It's no longer negative infinity to infinity. My range has a gap at that horizontal asymptote of positive 2. So my range is negative infinity to negative 2, union, positive 2 for my asymptote. Set positive 2. Union 2 to infinity. My x and y intercepts I see on the graph right at the origin, 0, 0. And that is another advanced rational function graphed.